So I'm not sure if you I kind of read my bio or anything, but you probably noticed that I have a lot of background in machine learning, AI, and data science. However, surprisingly, believe it or not, I actually did not begin my career as a data scientist. Right? Now, the reason is because I've been doing this so early that my company don't even know what to call me, okay? Because data science was not even a term in the English lexicon. There were no data scientists, there were no data science, you know. So when I started in the industry, coming out of school, this is a much, much younger version of myself, they call me an analytics engineer, okay? Because there were no data scientists, okay? And subsequently, of course, I have, you know, the term data scientist came about, and they call me data scientist and, you know, principal scientist, chief scientist, and so on. But I am still doing the same thing, okay? So even though my title have changed a few times. Okay, so from Seren's introduction, you probably know that, you know, so this background, I kind of grew out of the consumer web DNA. So I've seen this evolution of the consumer web from 1.0, where it's like everything is e-commerce centric and desktop centric, to the web 2.0, where everything is social and mobile, everything's on the cloud, okay? And now we are moving on to this web 3.0, where everything is compute on the edge, AI, and decentralization through blockchain and so on, right? So this is a very exciting time for us, definitely. There is a kind of term in the consumer web world that customer is king. Okay, so every online kind of startup that I work with in the Silicon Valley is always trying to figure out, you know, who's their customer, what they want, what they like, where they are, when they're there, and how to deliver their product and services to them. Okay, and because customer is king, you know, personalization is heavy. You know, it's the norm in this world, because if you don't personalize it, you're not going to grab people's attention. You're not going to, and they're not going to stay with you. Okay, so this is a norm. Okay, now from Seren's introduction, you may also realize that I actually have no airline background. I have zero airline background. Okay, and I have no revenue management background at all. You know, in fact, I don't even know what RM stands for, you know, when I joined Pros. You know, I saw, oh, is that a Linux command RM? Is that just deleting a file or something like that? So, you know, that was so coming to Pros has been a journey of learning and discovery for me. And I certainly learned a lot. And I think I just want to share a little bit of that learning with you. So obviously, I'm not an expert in RM, okay? I'm learning myself as well, okay? So this has been interesting, but I thought it's instructive. Okay, so when I joined Pros, you know, I basically, people like Justin Jander have to give me a revenue management 101. Okay, basically, I was told that, you know, the ultimate goal of revenue management is to make the right offer to the right customer at the right time, at the right price, through the right channel. Okay, and somehow that reminded me of something that I've just seen, just told you a little bit while ago in the consumer web, right? Except, you know, the how to deliver, this is like a how much, more like, right? Other than that, it's really the same thing, right? So this is really interesting to me, right? So the question that I obviously move into is, well, how do you achieve that, right? So then, you know, they give me this revenue management kind of primer, you know, basically says that all of you probably, you know, this is baby stuff for you, okay? So, but just bear with me, okay? So obviously in revenue management system, you have a forecasting system, right? Obviously no forecast is ever perfect, right? So you can influence that forecast and then optimize that to give you a bid price. And then that bid price actually represents the opportunity cost for selling the seat right now, right? And this is and it has as you can see here, there is a time component, right? How long before departure, and a price, right? So this bid price actually is not a price, okay? It's actually opportunity cost, right? So what that means is that if you have this published fare, right, you are gonna basically close everything below that bid price, because, you know, the opportunity cost would be, you know, higher if you sell it below that price, right? So that makes perfect sense. Actually, it's a very good control. So what that means is that the customer is going to see a fare, the lowest fare of 300, right? Now, based on what the customer decide to buy or not, right, this actually feeds back to update your forecasting system, right? So you've seen this. This is baby stuff for you, right? But what's interesting is that, well, something is, triggers my mind a little bit. Right? So this looks like it's automating the generation of a bid price, right? And it's learning, right? It's learning from the information it gets from the market to update this bid price. So this bid price is the better bid price, the better control, right? So now, I see some familiar faces here for people who attended my workshop on the first day, right? So what does this look like? If you remember my definition of AI, right? AI is a machine mimicry of human behavior with two important characteristics. One is to automate human decisions and subsequent action, and the other one is to learn, to improve its performance, right? And it looks like we just have that here, doesn't it? Okay? So now the interesting is like, well, why didn't pros call it their system AI, right? Right? Why didn't pros call them the system AI? Could it be that pros was doing AI so early that they didn't know what to call it back then? Right? That comes to my mind as a striking. That may be a possibility. But I thought about this for a while. That can't be true because AI's been around, in the 50s and 60s. And pros certainly hasn't been around that long, right? But what's interesting is that, for most of us here today, it's probably very difficult for you to imagine that AI actually there was a time when AI had a bad press, okay? AI was seen as something bad and terrible and not successful. If you do a little research, you know that this time is called the AI winter, okay? In fact, if you actually dig a little deeper, there's actually 2 different winters of AI. Go and Google it, you'll find it, okay? AI winter, yeah. Some people say it's 1 period, some people say it's 2 different winter, but it's around that time frame, okay? So why pros did not call their revenue management system an AI? I can only imagine, okay? I don't know what the answer is. Maybe Surin could tell me, right? Okay, so there were winters, okay? So anyway, so now if you actually do a little bit of further digging, right, and investigation of what the system actually do, it is actually what we call a model-based reinforcement learning, okay? So it's the model-based reinforcement learning. It's a reinforcement learning based on the known mechanism of how these data is generated. So you have a mechanism here of how these data is generated, right? Okay, so now, what about, how does that relate to what we call reinforcement learning today, right? How that's related to that is really if you could just replace this entire mechanism with a black box, with a neural network, okay? If you replace this whole thing with a black box neural network, then that's what we call a model-free reinforcement learning. So a lot of times people say reinforcement learning today, they refer to this, okay? But it really includes a model-based as well, okay? So now, there are certainly advantages and disadvantages of both, okay? So the greatest disadvantage of a model-free approach is the fact that it's model-free, right? There's no assumption of what the mechanism is, right? So the greatest advantage is flexibility and generality, right? You could use the same neural network to build this type of predictive system. You could use it to build ChatGPT. You could use it to build our Gen 4 price prediction algorithm. You can use it to build anything, right? It's general architecture. But there's also limitation, right? And the limitation is where this model-based approach really shines, okay? Because you open this black box. You can see what's inside it, right? There's interpretability. There's transparency, right? Coming with that transparency is the ability to manipulate, right? To manipulate, manipulability. If you don't like the forecast here, you can influence it. If it was a black box, if you don't like the forecast, tough luck, right? It will learn. Yes, some people say it will learn. Yes, it will learn, but how long? I don't know, right? Right? So that's the problem, okay? And another thing that's really great about this model-based reinforcement learning is the fact that it's actually very data efficient because you have the data are used to actually fully to predict the outcome rather to learn this mechanism because the mechanism is already known. Right? The mechanism is already known. You don't need data to tell you how the mechanism actually works, right? So, okay, so it's more data efficient. Now, so it looks like this approach, this conventional RM, can already give us the right time and the right price, right? But can it really give us the right price, though? Let me think about this. Because if you have a consumer whose willingness to pay is only $250, right, and you offer him the $300 fare, what is he going to do? He's going to leave, right? So if you really cannot get the right price without considering people's willingness to pay, right? You have to consider people's willingness to pay. The question is, how do you do that? How do you incorporate people's willingness to pay into your conventional revenue management system, right? So now let's look at this a little deeper, right? So this marginal opportunity cost, right? It is what we call a low-end control. It's an entry point control, right? It basically tells you to close all the fares below the bid price because that's the opportunity cost, right? So if you shouldn't sell it below the opportunity cost because you could get better price later, right? So now this low-end control is, I would say, effective when you have a substantial demand in the market, when the plane is capacity constrained, right? But during say a demand shock, such as COVID, is not very effective, right? Because what does that mean? When you have a bid price, the opportunity cost, right, is essentially zero. Because if you save the seat now, how much could you sell it for later? If the demand is so low, you're not going to be able to sell it for anything either, right? So the opportunity cost is zero, right? So telling the airline to not sell their fare below zero is not a useful piece of information, right? So everybody knows that. So what's needed is really, you need to tell them what people's opportunity to pay is also, right? Because you could price as high as people's willingness to pay for that fare, for that seat, right? Okay, so how do we accomplish that? The typical inputs to revenue management system is really seasonality, holiday, special events, availability, and the bookings on hand, right? So to get at the willingness to pay, you need a price, right? Without the price information, you're never going to figure out what people's willingness to pay is, right? So you need a price, but then we need some assumptions. So basically, this is actually the willingness to pay model, right? Assumption, right? So this is at different price, what are people's willingness to pay? What is the demand level, right? So we assume this to be some kind of exponential demand response, okay, which has this form. Now, what happens when you assume this, right? If you assume this, you all know from your Econ 101 that this little rectangle represents revenue, right? Because they're just price times the booking, right? So the price times the booking is basically give you the revenue, okay? So if I write that down, revenue is equal to total revenue is B, which is booking times price, right? What's the margin? The margin is booking, right, times price minus the cost, right? Where did you get that cost? Well, you have the opportunity cost, don't you, right? You have the opportunity cost, right? So why not just use that as your bid price here as opportunity cost, right? It's the cost, right? So now, how do you find the price that you get the optimal margin? How do you get that? How do you get that? You remember your calculus? Calculus? Okay? So how do you optimize anything? You take the derivative of that with respect to price, and then you set it to zero, right? Right? So to do that, we take the derivative with the margin, total margin, right, which is derivative of essentially the booking, right, times P minus C, the price minus the cost, opportunity cost, which is bid price, right? Okay? So this is a derivative of a product term, right? So basically that's derivative of, this is the first times the derivative of the second term, which is just 1. And then second term right here times the derivative of the first. The derivative of the first is exponential. Derivative of exponential is exponential times the derivative of the inside with respect to price is just minus 1 over A, alpha, right? Simple calculus. Remember that? Okay. All right. So if you remember that, this is the easy part. You've done all the hard part now. The rest of it easy, right? The rest of it, basically, you could factor out this exponential term, right? And set it equal to 0. And because this exponential is never 0, right, you could just wipe it out. You could solve for the optimal price here, right? Basically, that's just you move things on the other side, and you solve for the optimal price is this P optimal is equal to the opportunity cost plus this alpha parameter. Okay? Wow. What? We estimate it here, right? We estimate it through this. Yeah, we'll show you how to get that, okay? All right. So it turns out that, really, if you have this exponential kind of demand model, this willingness to pay model, right? Basically, the optimal price essentially is this bid price, which is the cost here, right? Plus this alpha, this is a gap here, and there you get your optimal price, right? The price that gives you the optimal margin, right? Okay, so now, having the willingness to pay alone, is that good enough? Is that good enough? Turns out that's actually not good enough, okay? Because if you have a kind of a class-based fare structure, right? These are not moving to this continuous pricing. What will happen? Basically, yeah, I know what his willingness to pay is. Like say, but then for each one of these fare, there's a fare fences. For example, these are there in each one of these fare essentially are associated with a certain class, certain kind of entitlement, right? For example, this is a very low price fare, so you only allow to seat an economy seat, no refund, no exchange, no baggage, right? But say this leisure traveler here, he's a long haul backpacker, okay? He has a huge luggage, so he obviously needs bags, right? And he has an 8-hour layover, right? And if the next class that allows the baggage is here, and his willingness to pay is only here, what's going to happen? You're going to lose him also, right? You're going to lose him also, because he's not willing to pay for that, okay? On the other hand, the other extreme, right? What happened, so basically these little, blue kind of shaded here represents the lost revenue opportunity, right? So anytime you have this kind of rigid fare structure, you're always going to have some lost opportunity, right? There's always some, steps, that will give you a little triangle. It may be very, very small, but you're still going to be lost revenue opportunity, right? So on the other hand, right, you have this business traveler here, right? His willingness to pay may be very, very high, and his fare is entitled him to a whole bunch of things, but he may not want all those things. He may not want all of them, right? For example, this is a business traveler. He is a frequent flyer, short-haul flyer. He takes the same flight every single week, right? So he doesn't need that. He doesn't need to have a refund exchange. He knows he's going to take flight every single week anyway, right? Because he flies so often, he always arrives like 30 minutes just right before the flight departs and just hop in the plane, right? And he always just works on the flight. He never, so he never gets to use the lounge. He never really eats or watch any movies on the flight, right? And being such a frequent flyer, he's conscientious about the environment, right? So he, don't like to waste food, So he actually really don't want to eat a meal, but he's entitled to it, right? So if you've given him the choice, right, really what he wanted is just economy seat and Wi-Fi to work, right? And if you have some extra money, he probably will buy a carbon offset to make himself feel better about, the environment because his flight is so frequent. On the other hand, right, this, leisure traveler here, he had an 8-hour layover, right? He said, really, really nice if I could have access to the lounge so I could rest, right? But he would never pay for the fare that would entitle him to the lounge, right? Okay, so now, this is the thing, right? Knowing how much a customer is willing to pay is not the same as knowing what they want to pay for, okay? I want to spend, I'm willing to pay, $500 for fare, but I don't want to spend it on food. I'm a foodie, I want to eat good food, or whatever, something like that, right? Okay, so now, what we really need is what we call continuous pricing, right? Continuous pricing, basically there's no, essentially, kind of these fare fences, right? So if you have that, you basically decouple the seats from all the ancillary. Basically, this whole thing is just this price of a seat based on the different willingness to pay at different time, right? Okay, so everything is basically a product now, not just a seat, right? Or every ancillary, every service is really just a product, right? So what that gives people is the flexibility. You can actually choose what you want, right? And so we've seen this kind of thing in the consumer web world already, because giving people flexibility is actually a good thing. So early on, in the telco, they actually had these pre-bundle phone contracts. They've largely disappeared, right? Because it's just not competitive. People want this flexibility. They want to choose what they want. If I want a 1-year contract, I'll buy a 1-year contract. If I want a replacement phone kind of insurance, I'll buy that add-on. If I want to replace, exchangeable fare, I'll buy that as an add-on, right? give people the flexibility, right? Okay, so now with that understanding, right, what does this future AI-augmented airline retail look like? Well, first, we're obviously going to have RM. We have conventional RM. So with willingness to pay, right, we can get the right time. We can get the right time. And we talk about this is really just model-based reinforcement learning, which is, AI in a sense, right? Okay. So we also talk about getting the right price, right? So if you have continuous pricing with a willingness to pay model, right, you can actually get the right price, right? So the question you ask right here up front is, how do you get that alpha, right? How do you get the alpha? And that's actually obtained with online learning through with variational inference. Okay, so we can go into the detail of that, but I don't want to do that right now. Okay, what about the right offer? What about the right offer, right? So you hear Justin talk about we have the ability to construct offer, right? We have the ability, we have a lot of ancillary science that can help you rank what offer to display, right? Bundle them together, right? And also price them, right? Okay, now because this, so this is actually all done through what we call reinforcement learning, which is not a random number generator, okay? Now it's through systematic exploration of the possible prices that you may never have explored before, okay? And when people actually latch onto willing to pay for that, at those price, you get the right price, right? So that's, but I draw on this as kind of wall off here because this pricing is kind of done right now, kind of done independent of the pricing of the seat. Because today, I would say many airlines, the ancillary service is actually a completely different department, okay? So it's actually done separately today, okay? So how about the right channel? The right channel. Well, if there's anything you learn from the consumer web, is that like in the consumer web, there's so many different channels. Every website, everywhere you go on digitally, right, is a channel, right? So you can never be everywhere, right? So what do? They do, basically they say, since it's impossible to be everywhere the consumer is, what they do is that they put clickable ads everywhere and then funnel them in, bring them in, right? And we do this by fair marketing, right? We do this by fair marketing. And with fair marketing, since it's marketing technology, right, you can already leverage all the personalization technology, hyper-personalization technology, right, to help us personalize these kind of offer and fair marketing, okay? Okay, finally, the most important thing, the customer is king, right? So how do you get the right customer? So most of the airlines' operational decisions are based on two types of customer, right? There's a leisure customer and there's a business traveler, right? Now, if I tell you that all of you here only belong to two classes, male and female, right? I don't know anything about you, right? I basically don't know anything about you, right? So what that means is like, airlines don't really know their customer very well, okay? So if you don't know their customer well, you can't be customer-centric, right? You can't be customer-centric if you don't know your customer, at a detailed level. So in fact, airlines are not known to be very customer-centric, and most of them are, very process-centric, right? I mean, except some of the newcomers that we heard from this morning. So they're very process-centric. So the question is actually, how do you get to know your customer better? How can you accomplish that? And that we do it through what we call request-specific pricing. So at the time of the request, I have a lot more data about the customer, about the trip, right? So I could price it better, okay, based on the context of that request, right? Are you staying over the weekend? Are you traveling alone? Are you traveling with children? You see that in the demo from Justin, right, in the main stage, right? So this is actually done through an algorithm called double debiased neural network-based robust estimation. So that's a mouthful, right? So what does it actually mean? What does it actually mean, okay? So it really is a two-stage semi-parametric model, right? Semi-parametric just means it has some component that's parametric, some component that's actually non-parametric, okay? So the two-stage really is, the first stage is really what we call a deep neural network. You use a deep neural network to estimate both the booking and the price, okay, separately, okay, independently. So since you estimate them independently, because each one of them is associated with each other, right? You can actually still plot them on this price and demand plot here, right? It could look something like that, okay? Right? So, but once you have that data, the next stage is what we call robust price sensitivity estimation, okay? So we want to estimate the price sensitivity, which essentially is captures by this alpha parameter here, okay? So what comes out of this second step is basically this alpha. Once you have this alpha, you can plot this curve, right? You have this curve. You have this willingness to pay curve, essentially, okay? So now, if you are doing this right now, okay? So if you don't have continuous pricing, if you're doing this right now, okay, you can do what we call fare transformation. Okay, what that means is that if you have already published a set of fare that looks like this, okay, you have these kind of fare price and fare structure like that. If you have a bid price, right, that you get from previous your revenue management system, and it's like $295, as I said before, and at a capacity of 25, 30 days before departure, what would you do? You close everything below that $295, right? So everything will be below class Q and below, right? Okay, so now what happens when you have alpha? If you have this alpha, you can also compute the incremental demand, right? If you open class A, there's probably you can actually compute it, right? Plug alpha into this formula, and you estimate lambda also you get that from your revenue management system, right? And then you would get, for example, a value, say 15, okay? And then now what happens when you actually open class B, right? You would get 20, right? You could do that for every class. You would get all the incremental demand for every class because you have this curve, right? You have this entire curve, all right? Now, what does that allow you to do? You could do fare buy-down adjustment of fare, right? For example, let's do this for class B, okay? So if you open class B, you would gain 20 people from buying the $500 fare, which is 10,000, right? But you also lost some revenue from the fact that you have 15 people who normally would have paid $600 for this class Y. Now, because this class B is fare, they buy down. So now you have this different, right? Because now they buy down, they only spend $500. So you lost $100 from each one of these 15 people is $1,500, right? If you take this gain minus the loss, you would get the buy down adjusted fare. Right? So this fare right here is not really worth $500. It's actually worth only $425. That's what it's telling you, okay? So what does that mean? You could use this. You could use your same bid price, but you could do this for every class, right? Since you have the incremental demand for every class, right? You could do that for every class, and that give you a new reference, right? So now if you use this, if you look at this bid price again, you say $295. I want to close everything below $295. You would close everything H and below, okay? So that's how you get this, how do you use this request-specific pricing now, right? Even when you don't have continuous pricing. So what about the future? If we have continuous pricing, what will happen? Then it becomes very, very simple, right? You simply, look at this. You simply take this $295, this bid price, right? And you add it to whatever this alpha parameter the estimate is, from variation to inference, whatever that is, right? You just add it together, and that is the price. That is the price you offer. That's it, okay? And that not need to be a published fare. It's whatever it is, just offer that, right? Okay? So now, one thing that's really interesting is that because this first stage, because it's a neural network, it's very flexible. You can use it to ingest many, many additional, I would say, data or predictors or additional kind of covariates, right? For example, you could use, and also at the time of the request, right, you can also get a much more accurate contextual data reliably. You can also collect a lot more of those data. You would know, like, for example, for example, the economic condition at the time when when he actually buy, right? You could get a lot of this data much more reliably, right? So you can actually get all those data. For example, right? You could get competitor fare, right? At the time you actually make the request, right? You could just see what the competitor fare is, right? If you want to predict that in advance, that's very hard, right? But at the time of the request, you could get that, right? You get competitor fare, you could get the flight search, what he's shopping for, what his destination is shopping for. Maybe he didn't shop for one location. Maybe he searched for several different locations, right? What events is going on, what his loyalty status was, right? What's the weather condition, what's the economic indicator? You get all this and much more. You can even get his social media if you opt in to do so, right? Okay, so what does that mean? That means if you have a lot more of this contextual data, you know the customer a lot more with a lot greater granularity. You know the customer, who he is, what kind of traveler he is, right? So that allows you to estimate this alpha much, much better. And if you estimate this alpha much, much accurately, you have much more capacity to capture revenue, right? Much better, I would say, capture more revenue that way, right? But at the same time, this is actually a strange thing, at the same time, the customers are happier, right? Because they get a much more personalized offer, right? So this is sort of the airline's way of doing personalization, right? Request-specific pricing, okay? All right, so that's how you get from process-centric, right, to be more customer-centric. All right, so now, investing in customer centricity is really, really worth it. So Forrester actually had a report, saying that, I think his title called "Is Customer Obsession Worth It?" Okay, and it turns out it's totally worth it. They have basically quantified that customer-obsessed company have a revenue growth 2.5 times better. The customer retention is 2.2 times better. And if you actually look at the different levels of customer centricity, right? If you are just customer aware, that's not very customer, a little customer centric, like customer engaged, a little more customer centric, customer committed, and customer obsessed, right? So how they quantify which bucket you fall into, that's detail, okay? But the trend that I want you to focus on is that the more customer-centric you are, the bigger the ROI. In fact, you can recover your return on investment in 3 years, okay? And moreover, in 6 years, you would have recovered about 200% of your ROI. You will have 200% ROI, and in 12 years, you have 700% ROI, okay? Because these things compound over years, okay? And if that study alone is not enough to convince you, there's actually more, okay? What's the value of a better customer experience? So Watermark Consulting actually did this a very amazing study, okay? Basically, they quantify the company that are leaders in customer experience versus the market average, okay? Basically, look at their stock performance. Compare that to the laggers who actually don't care about customer experience, okay? And the result is very stark, okay? You don't need a PhD to see that, The leaders does better than the market, and the laggers do worse. And guess what? They did this study over and over again, year after year, and you see the same pattern year after year after year, okay? Believe it now? Okay? So now, but the thing is, being customer-centric is scary, right? There's GDPR, right? You can't, everybody's afraid of doing something that's discriminative pricing, right? But using customer data. But keep in mind, GDPR never says you cannot use customer data. GDPR just says you have to respect customers' choice. If they want you to use it, you could use it. If they don't want you to use it, you cannot use it. They have the option to opt out, right? So what's the trick? What do the consumer web do? The consumer web basically learned that, well, you just have to provide a value proposition you can't refuse, right? How do you create a value proposition you can't refuse? Let me give you one example, okay? So your second-to-second location data, right? These are what we call precise spatial temporal data of where you are. Every second of the day, your precise location of where you are. These data are very, very private, right? Who would give this data to anyone else? Right? I mean, seriously, we probably don't share this data with anyone else except probably the closest of our family members, right? Maybe kids or elderly parents or something like that, right? Okay, so nobody wants to share this, right? But guess what? What is the value? If I give you a value proposition that if you lose your phone, I can help you find it. Is that enough to get people to opt in? A lot of people opt in. How many people actually have Find My Phone function turned on here? Lots of you, right? That's a value proposition. Is so good, you can't refuse, okay? Whatever that value proposition is from the airline, I'll leave it to you to figure out, okay? But if you make that value proposition, customers are perfectly willing to opt in their data to exchange for that, okay? All right. So as with any great journey, there's always, I would say, some detours and excursions, okay? So I'm going to take you on a short detour, Okay, so this is actually kind of interesting on my journey to pros. Okay, so I remember this is my journey, my learning journey. Okay, so so one of the things when I came to pros is I'm actually very curious about one thing. You know, pros have two sides of the business, right? There's the airline side, the product, the flagship product is revenue management, but then there's also the B2B side. You know, most of their product, boils down to some kind of, if you look at it at an algorithmic level, it boils down to some kind of willingness to pay, right? If I actually look into the product and the algorithm, right, they look nothing alike each other, okay? They're nothing like each other. So I wonder, why isn't pros two company, right? Have you ever wondered about that? Ever wonder about that? Yeah, I wonder about that too, right? So now it took me a while to figure this out, but I figured it out. You know, it turns out that there's actually a deep connection. If you go back to your Econ 101, okay, basically this, we know there's a notion of optimal price, right? The optimal price is the equilibrium price, right? If you learned that from your Econ 101. And the equilibrium price happens when you have supply matching your demand, right? Now, most supply and demand curve don't look like straight lines like this. This is a textbook example, right? Most supply and demand curve are kind of, much more curvy and complex, okay? So these are straight lines are probably a local approximation at best, right? And you know that, how do we, now the curious thing is like, how do you get from this simple idea of matching supply and demand to revenue management, and how do you get from here to willingness to pay estimation, okay? So now that's an interesting exercise. Basically, I didn't figure this out until I was leading a team and building some, a scientist doing some research on using shopping data to help with revenue management. So turns out that, these two sides are actually very related, okay? So for the airline side, what we want to do is help airline price a seat, right? So if you know anything about the seat on the plane, is that their supply is limited, right? So what that means is that supply of the seat is relatively inelastic, okay? And that's actually illustrated by the fact that this supply curve is nearly vertical here, right? It's relatively inelastic. What does that mean? That means as demand changes, airlines don't really have a good way to change the supply of their seats, right? Okay? If you need like more clickers, right? You just order more clicker. If there's more demand for clicker, you just order them, right? But airline can't do that, right? If there's more demand airline cannot put more seats in the plane, right? So instead, what do they do? So there are little things they could do, right? For minor adjustment, they swap in a bigger plane, but after kind of network planning, right, the capacity for a market is typically kind of roughly fixed, right? You can do small adjustment, but largely they're fixed, okay? So what do airlines do? They basically change the price to shift the demand, to control the demand, right? So if your demand is too low, then you lower the price to shift the demand higher, back to this equilibrium, right? If your demand is too high, you raise the price to shift it back down, right? So you change price to shift demand, okay? So what does this need? This needs essentially, predictability in people's travel behavior, right? You need predictable demand. And turns out that people's kind of travel behavior are very predictable, okay? In fact, people's behavior in general are very so predictable. There are people who've written books on how predictable we are. In fact, we are what we call predictably irrational. Everybody read that book? Right? Our behaviors are very, very predictable, okay? So because airlines could do this, right? Basically, they predict people's future travel demand and then match to their remaining capacity at a future time, right? That's the essence of revenue management, right? You maintain that equilibrium, okay? That's really the essence of it, right? What about so you know all this, right, probably, right? But what about on the B2B side? On the B2B side is where it's kind of interesting, right? Because on the B2B side, because of globalization, we have pretty much, infinite kind of production capacity, right? What that means is that you are operating in this kind of infinite supply range, okay? And in that infinite supply range, something very interesting happened. One thing that happened is that, this supply curve here is very flat, okay? Why? Why is that flat? Because economy of scale, right? If you are able to produce millions and millions of units of this clicker to supply the global market, producing one more unit, it's not going to cost you very much, right? So the marginal cost of production is almost like zero, right? That's why this is so flat. It's producing any more quantity doesn't actually cost you more, okay? Got that curve, okay? All right? And now, not only is it flat, it's also very stable because the market is very competitive, right? The market is competitive because what it means is that if you cannot buy the clicker from one vendor, you could buy it from another vendor. You could find a similar clicker from another vendor for probably around the same price, right? The market is so competitive, so this not only is it flat, it's actually very stable, right? So what does that mean for B2B pricing or retail pricing? You could just treat this supply cost as a fixed cost, right? Regardless of how demand changes, the supply cost doesn't really change much, right? So you can just focus on estimating this demand elasticity, right? Okay, now the only thing that I want to say is that, right, the difference between B2B and retail pricing, okay, so before I get there, right, so what's needed to do this is to maintain this, for this assumption to be true, for this supply cost to be a fixed cost, right, that doesn't change, is that you need a efficient supply chain, right, to keep this supply cost constant, right, okay? Because if the market is not competitive, right, some people could charge higher, right, then you're not going to get this stable this supply cost here, right, okay. So now this is, okay, so now the only thing I want to say is that B2B pricing, the difference between B2B and retail is that B2B pricing is negotiated, right? So what it means is that you don't even have to price at equilibrium. You can actually price around this equilibrium, right, based on whatever business contact, business relationship you have with the buyer, right? So that's why, most B2B pricing basically boils down to willingness to pay, estimation. Right? You see that? Okay? So now, both sides of this pros business, right? The B2B side and the airline were doing pretty well before this disruption of the century, before COVID, right? What did COVID did? COVID disrupted people's travel behavior, so you no longer can predict people's future travel pattern anymore, right? Okay? So it used to be the case that airline can take years and years and years of data to forecast far out into the future, up to about a year, right? You can buy a ticket for a departure a year from today, right? And the reason you could do that is because the airline must have a reasonable idea of what the future demand a year from now, right? In order to be able to sell you that ticket at a price, right? Otherwise, they can't price it, right? So they can forecast that all the way out to about a year. But with COVID, basically, this long history out here, years and years history probably is not relevant, right? Short histories are still relevant, okay? Still relevant, because still tells you what's going on recently, right? So, what that means is you can forecast only a short window into the future, right? So what that means is everything gets squeezed around this time. So this is called the temporal squeeze problem, right? You have less relevant history, you can predict less of the window into the future, okay? So it turns out that, this demand volatility, high demand volatility and short history, short forecast, is actually the norm in B2B and retail, especially in retail, right? Most retailers don't even forecast their demand a few months out. A quarter probably is what they do, okay? They do it quarter to quarter, okay? So, and what do they do to help them forecast their demand better, right? Because they can't use more of the history, right? Because demand is so volatile, right? So they use more different kinds of data, right? So it's actually very common for a marketer or CMO to use everything from transaction to clickstream to social media impression to everything there, take every piece of data they can get their hands on to help forecast the demand for their product and service, right? Okay, and guess what? COVID also disrupted supply chain, right? We no longer have infinite supply of product anymore, right? In fact, if you go to your store, right, you're constantly out of stock. That's a problem, right? So you can't treat the cost of your supply as fixed cost anymore. You have to factor that into your pricing, Okay? In fact, even shipping costs have become more volatile these days, right? Okay, so guess what? This is a problem that airline have been solving for years with their revenue management practice, right? Because airline, the seat is always constrained. You always have a limited supply of seats, right? You always have to price a seat in a supply cost aware manner. We call capacity aware, but capacity for airline is just really the supply of their goods, their seats. Okay? That's the connection, okay? So what do the airlines do? They do forecast and optimize, right, to solve this problem. And as you can see, the challenge for one side is an expertise on the other side, right? Okay? You see that? Okay? So who do you think is the best at facilitating this learning, right? I challenge you to name one other company in this entire world that have the operation on both sides, okay, the science on both sides, the working experience on both sides, and the product suite that covers both sides. I don't think you can name another one besides pros. Okay? All right. Okay, now the interesting thing, coming out of this detour, okay, I took you on a detour, right, this journey. Coming out of this detour is that, well, revenue management actually can, airline side of the revenue management side can actually learn a lot from the B2B and retail pricing. And B2B retail pricing can also learn a lot from revenue management, right? So revenue management can actually learn to use more third-party data, right? We are using competitive fare, shopping data, events data. These are research that we've done, my team and I have done during COVID, right? And the willingness to pay actually, learn a lot from the RM side as well. They do forecast and optimize. Basically that Gen 4, pricing optimization that you see in the keynote is actually a learning from the airline side, right? Because there's a two-stage. There's a willingness to pay price prediction with neural network and an optimization process, to optimize the recommended price, right? And we also developed something in between, right? Capacity-aware optimization. So that's kind of somewhere in between. So what does B2B pricing have, anything to do with airline RM? It actually makes your, airline revenue management much more resilient. Resilient even to something as big as COVID, okay? Okay, so the connection is really that, this two extreme is really just the two different extremes of this elasticity of the supply. Okay? On the B2B side, you have almost perfectly elastic supply here. And on the airline side, you have almost perfectly inelastic supply here. Okay? That's it. So now it makes perfect sense that Pros is actually one company, not two. Okay? But what does that mean to the future of this AI-augmented airline retail? Okay? What does that mean? What that means is that it is starting to break down these walls right here, these walls right here. So fare marketing is actually done in a digital department that's completely separate from RM, and similarly for ancillary services. But doing this, we can break down this wall because we are actually using shopping data that we actually get from fare marketing platform to inform revenue management. Because these actually could tell you, it's a very good, I would say, because people look before they book, right? So it's a very good indicator of future demand, right? So it can help you forecast demand better, then you can actually do RM better, right? But RM also can actually inform fare marketing too, because you could see the load factor on different market and use that to tell your fare marketing where should you focus your marketing dollar be, right? You should focus your marketing dollar on this market because the load factor is low here. These market, the load factor is already pretty high, don't need to market anymore here, right? Okay? All right. Now, it also helps us break down this wall because now with request-specific pricing, right? The request-specific pricing, you can get a lot of context of who this customer is, right? You can actually construct the perfect offer for this customer, the right offer for that customer, right? And that also helps us kind of, with offer and order management specifically, now you have much better data, cleaner data to actually help you do RM better as well, okay? So this is actually how I got here, okay? This is my circuitous journey to get here, to where I am today. But the road ahead is still long, because we're still long ways to get to this fully AI-augmented airline retail, okay? So this is just the beginning, okay? So I invite you to join me, because I will be on this journey. I'll be continuing to learn from all the experts, from all the customers of ours, okay? And if we do it together, it'll be more fun. And more importantly, if we do it together, we all get there faster. So let's take flight together. Thank you.